Right, we're looking at this diagram, and notice that we've been told that segment DG, that's a ray DG and segment DF are perpendicular. So perpendicular segments, they're going to form that right angle. So ray DG is perpendicular with segment DF. So that means that this is going to be a right angle. Because of that, we'll know that angles 2 and 3 are complementary. They'll add up to 90 degrees. So keep that in mind. All right, the sides of angle 4. Angle 4 is this region where D is the vertex. The sides of angle 4 are ray DC and ray DG. Both of those are rays, ray DC and ray DG. The vertex of angle 2, so angle 2 is this region formed by these two rays, but the vertex is this point, and that's going to be point D. Another name for angle 3 is this region. All these angles have D as their vertex. E is on one side of angle 3 and G is on the other, with D being the vertex, so we can call that angle EDG. Classify angle 5. I don't really like this question because we're going off of appearances, but it appears to be less than 90. It appears to be acute. Classify angle CDE. So CDE is actually just formed by two opposite rays. This is just a line. Some books refer to that as a straight angle. Okay, if the measure, I'm going to do this in pencil so I can erase. If the measure of angle 5 is 42 degrees and the measure of angle 1 is 117 degrees, find the measure of angle CDF. Well, CDF is what you get when you add those two parts together. The part plus the part equals the whole. So we'll just want to add those two measures. So when we do that, we're going to end up with 159 degrees. All right, in number 7, if angle 3 is 73 degrees, find the measure of angle FDE. And remember earlier we mentioned that these two angles are complementary. Together they're going to add to 90. So we can just subtract 73 degrees from 90, and that's going to leave us with 17 degrees. Okay, in number 8, we are told that ray BC bisects angle FBE. Ray BC, this is the pair of scissors that bisects FBE. So that means that this part is going to be equal to that part in measure. All right, again, I think I'll write in pencil just in case I need to erase. So if ABF, that's this, ABF is 7x plus 20, and FBC, which is this little part here, is 2x minus 5, and ABC is 159, we want to find the value of x. All right, this is actually quite tricky. ABC is all of that. That's 159. So the only thing that I haven't labeled is this little piece right here. And notice that we already said these two were equal. So this one would also be 2x minus 5. So in this problem, rather than looking at a single angle, I think we're going to have to go with the full 360-degree rotation. If we add all those parts together, we're going to get 360. So I'm just going to list them one by one. We have 7x plus 20 plus the 2x minus 5 appears twice, so 2 times 2x minus 5 plus the 159, and that equals 360. So let's clean up this left side over here. We'll go ahead and distribute through 4x minus 10. And then we'll combine our like terms. So 7x and 4x, we have 11x. 20 minus 10 is 10, and 10 plus 159 is going to be 169. That equals 360. We'll go ahead and subtract 169 from both sides, and then we'll need to divide by 11. So when we subtract 169 from both sides, we get 191. Divide that by 11, and we end up with a decimal. So I think these problems generally work out well on this paper. Let me just double check something and see if I've not made a mistake here. ABF, FB, C, and ABC. Okay, I looked at this angle wrong. I'm sorry. So this angle, let me highlight it. ABC is this angle. I lost the track of the C. So all of this is 159. So my apologies. Scratch all the rest of that. I'm sorry I looked at that wrong. This is just going to be part plus part equals the whole. This part plus that part. So 7x plus 20 plus 2x minus 5 is equal to the 159 degrees. Combine our like terms and we have 9x plus 15 equals 159. Subtract 15 from both sides and we have 144. Divide 144 by 9 and we end up with 16 for x. Sorry, okay? All right, in 9, we're using the same diagram, and unfortunately I made a mess of it. So let me just quickly resketch it here. So we have B, D. You don't have to redraw this unless I led you astray and you made a mess of things as well. Okay, and we said that these two parts were congruent to one another. All right, so let's use that. All right, so DBC is 12x minus 3. So angle DBC is this whole entire thing. I'm going to have a difficult time labeling that, so I'll come back to that. Angle DBE, which is just this piece, is 5x plus 12. And angle EBC, which is this piece, is 3x plus 13. And we want to find the measure of EBC. So in the end, I'll just need to know what x is. So DBC this is the whole. So once again, we're going to have the part plus the part equals the whole. Let me write this out the long way. So the measure of this angle, the measure of angle DBE, plus the measure of this angle, the measure of angle EBC, is equal to the whole thing, which in this case is DBC. All right, DBE is 5x plus 12. EBC is 3x plus 13. And DBC, the whole thing, is 12x minus 3. We'll group up our like terms. We have 8x plus 25. Let's subtract 8x from both sides. So 25 is equal to 4x minus 3. Add 3, 28 equals 4x, and x then is 7. But we want to find EBC, and EBC was the 3x plus 13. So the measure of angle EBC is 3 times x plus 13. So we found that x was 7 and we plugged it in right here. So 21 plus 13, or 34 degrees. All right, I'm going to use this picture one final time. So I'll erase what I wrote. And let's see what we've been given. So they give us the measure of FBC. FBC is this piece, that's 10x minus 9. and CBE, and that part is 4x plus 15. So we've been given expressions for the two equal pieces. Remember, we knew it was bisected, and in the end, we've been asked to find the measure of FBE, which is the whole entire thing. So we know that the two parts are going to be equal in measure. The measure of angle FBC is equal to the measure of angle CBE. FBC is 10x minus 9. CBE is 4x plus 15. Subtract 4x from both sides. 6x minus 9 equals 15. Add 9, 6x is 24. When we divide, we're going to get 4 for x. So to find the measure of FBE, let's plug it into this angle right here. So the measure of angle FBC is 10 times 4 minus 9. So x was 4, and I plugged it in right there. And 40 minus 9 is going to give us 31. But that is just half of the angle that we've been asked to find. We know those are two equal pieces. So the measure of the whole angle FBE is going to equal 31 times 2, or 62 degrees. Okay, on the back, we're classifying the angles. We do know that we have a pair of perpendicular lines. JL is perpendicular to MN, so we know that we've got a right angle there. All right, classify PKM. So PKM is here, and NKO is here. Well, these two angles are definitely vertical angles. They're not adjacent, they don't share a side, they're not complementary, they don't add up to 90, they don't add up to 180, and they don't form a linear pair. So that's all we can say about them. How about NKO and OKL? So NKO is the yellow angle that I just highlighted, and OKL is this angle here right next to it. So they do share that side. That's going to make them adjacent to one another. And together, these two angles also have to add up to 90, so they'll be complementary. And that's all we're going to be able to say about those angles. All right, using the same picture, if JKP is 67 degrees, what would the measure of PKL be? Well, JKP is this angle, and PKL is the rest of this rotation. And together, those two angles should be supplementary. So if we subtract 67 from 180, that's going to leave us with 113 degrees. And then we need the measure of NKO. Well, if we go back, if this is 67, we know that these two angles are complementary, so this would have to be 13 degrees in order for that, that would need to be 23 degrees in order for that to add up to 90. So if that's 23, so is this, 23 degrees. Okay? All right, so now we're using this diagram for the following questions. If angle 1 is 7x minus 19 and angle 2 is x plus 5, find the measure of 2. Well, notice that 1 and 2, they're going to have to be complementary because all three of these angles would have to add up to 180, and we've got a right angle there. So these two angles, the 7x minus 19 and the x plus 5, would need to add to 90. So we have 8x minus 14 equals 90, add 14. 8x is equal to 104, divide both sides by 8, and we're going to get that x is equal to 13. And once we know that's 13, we want to plug in right here. So the measure of angle 2 is going to be 13 plus 5, or 18 degrees. All right, what if 1 is 6x plus 25 and 4 is 10x minus 11? Well, 1 and 4 are vertical angles, so we know we can set those equal to one another. Vertical angles are always equal. Subtract 6x from both sides and we'll get 4x minus 11. Add 11, 36 equals 4x, divide by 4, and x is 9. And then once we know that x is 9, we're just going to want to plug it in right there to find 1. So the measure of angle 1 is 6 times 9 plus 25. 54 plus 25 is going to give us 79 degrees. All right, angle 4 and angle 5, we've been given measures for those. Well, 4 and 5 form a linear pair, so they're going to add up to 180. So 4 plus 5 equals 180. So 3x plus 7 plus 9x minus 43 equals 180. 12x minus 37 equals 180. Add 37 to both sides. I better double check that. Sorry, 36. Add 36 to both sides, and we're going to end up with 216. And then divide 216 by 12, and you get that x equals 18. We want to find the measure of UPS. UPS is this angle, and we know that this part is 90, so we just need to add the measure of UPT to that, or we're calling it angle 4. So here's angle 4, and we'll want to substitute in the 18 for the x. So the measure of angle 4 is 3 times 18 plus 7. 54 plus 7 is going to give us 61. So this is 61 degrees. So to get the measure of angle UPS, we want to add 90 and 61. So we end up with 151 degrees. Okay, if W and V are supplementary angles, we only use that picture for 15 through 17, so we're moving on. And V is 49, what's W? Well, supplementary angles are going to add up to 180, so we just need to do 180 minus 49, and that's going to give us 131 degrees. So this equals to 131. If 1 and 2 are vertical and 2 and 3 are complementary, find the measure of 1. Well, we know that 1 and 2 are equal to each other because vertical angles are equal in measure. If 3 is 56 and these are going to add up to 90 degrees together, then this needs to be 34 degrees. Those two would total 90. So if 2 is 34 degrees, so is angle 1. So the measure of angle 1 is 34 degrees. And then down here, we're going to just be doing the Pythagorean Theorem. So we're missing a leg. A squared plus 12 squared equals 13 squared. A squared plus 144 equals 169. Subtract 144 from both sides, and we're going to end up with 25. Take the square roots, and A is 5. In this case, we have 7 squared plus 24 squared equals, we're missing the hypotenuse, 49 plus 576 is equal to x squared. So that's going to be 625. And then when we take the square roots of both sides, 625 is a perfect square. The square root of 625 is 25. All right, number 22. This triangle has equal legs, so a leg squared plus a leg squared is going to equal the hypotenuse squared. We have 100 plus 100, 200, and then we'll take the square roots of both sides. So when we try to take the square root of 200, it's not a perfect square, and we'll learn to simplify that soon. There's a way to simplify it, but for now we're just rounding to the nearest tenths. So that's going to be about 14.1. And then down here we're finding the distance between these points. You're welcome to draw a triangle if that's your preference. I'm just going to quickly do the distance formula. So the second x minus the first x squared plus the second y minus the first y squared, and the square root of all of that. So we'll end up with the square root of 3 squared plus 4 squared The square root of 9 plus 16 is the square root of 25, and that equals 25. I'm sorry, 5. The square root of 25 is 5. In number 24, we have the second x minus the first x squared plus the second y minus the first y squared. Both of these will become addition. So we have the square root of 6 squared plus 10 squared. That's going to be the square root of 36 plus 100, or the square root of 136. And that's not a perfect square. And rounding to the hundredths place, it'll be 66 hundredths, 11.66. Finally, one last time, the second x minus the first x squared plus the second y minus the first y squared. That's going to become addition. So 5 plus 4, we end up with the square root of 9 squared, and this is going to be negative 3 squared. 9 times 9 is 81. Negative 3 times negative 3 is 9. So we have the square root of 90, which is also not a perfect square. So when we take the square root of that and round, it'll be 49. 9 and 49 hundredths.